Hey everybody, so we're doing a little check-in on a long-term project we have here. Somebody asked on one of our other videos about the Ducati Narrow Case single project that we got in here. I mistakenly in the video called it a wide case. My bad. We had just gotten the bike and I wasn't sure what I was getting into yet, and I hadn't looked that closely. But anyway, that's my excuse. What we were doing is taking a bike that was in pieces, that the motor had been built as a race motor and then plopped back into a street bike and run around kind of unsuccessfully because race motors, excuse me, make terrible street motors, believe it or not. So the customer asked me to make it back into a street bike for him. So he gave me a ton of parts. We've got some bins of stuff and some spares. And what I've done so far is tear the motor down and rebuild it with a stock piston. This one, actually, we changed the case on this. We changed the bottom end. No, okay. Details are escaping me now. There's a lot of parts came with the piles of parts came with these to make it. But basically, we're going to a mild cam, standard piston, and just a bike that's going to be more fun to ride on the street. A bike that'll idle and have low RPM power, which is far more advantageous when you're just trying to get around town or cruise the back roads. You can see in here we got our hairpin valve springs, different than the coils that are used in most things now, or all things now until you get into like pneumatics and stuff. These are very popular at one time. They're kind of cool. Can be kind of a pain to work with if you don't have the right tools, but yeah, they're kind of cool. And also these use a shim system to adjust the valves on top of your there's a valve lash cap kind of thing here. There's different shims. So like a modern double overhead cam motor where you have to shim it, this one has to be shimmed as well. This is not a Desmo head, hence the springs. So it uses springs to return the valve to its closed position. Desmo uses part of a camshaft, so it's all mechanical. This is a great up-close picture of what a bevel drive looks like. If you've ever been around Ducatis, you hear talk about bevel drive versus the rubber band motors, the cam belt motors. This is a bevel. It takes a beveled gear, has an angle or a bevel on it, changes the force from one direction to 90 degrees the other direction, and this is the end of your camshaft, driven off the crank down there via this bevel tower. So pretty simple and straightforward, and one of the kind of cool mechanical things that you don't see a lot of anymore because it's just not that economical to make, but they're cool and they're pretty reliable if you set them up right. This bike is a customer we've done. He's the same guy that has some of the other cool bikes you've seen in here. Not in a super rush for it, which is one of the reasons why we still have it. It's been about a year, but the hard stuff is pretty much done. We have electronic ignition to mount to it, which will again make starting easier. Actually, it's electronic ignition and charging system, so turns it into a 12 volt from the original 6 volt. Gets rid of a lot of the dodgy. The original system was pretty anemic. And it's also 60 years old now, so this gets it into a much more reliable thing. And the electric. This is not a Rick's Electric part. Our good buddies Rick's Electric up in New Hampshire. It's from the UK, but it's pretty bike specific thing, so not a generally largely manufactured part. But yeah, once we get that in there, it's pretty much just waiting for me to have the time to get back to it and throw it in the frame, fire it up, run it around, and see how it goes. So stay tuned. We'll have a video of it running soon. And then another thing people keep asking about, my Velocette short stroke race motor project. And so just got back into working on it too. Sadly, real life interferes. But what we've done is we've cut a pretty good squish band in the piston here. And what we're doing now is I'm just clearancing the exhaust valve continues to hit the piston, and so this may end up being a throwaway piston. I'm taking it down as far as I can to see how much room we have and how much thickness is left once we're done. And if it's thick enough, I'll know that I can make it work as this setup. If it's not, if it makes it too thin, I will have to probably lose a little compression, make a little more space, seat the valve a little bit more. I've also been grinding the valves, cutting the valves into the head to make some more clearance there. But as you can tell, it starts off life as a very thin valve seat, and there's not a lot to work with. So it's sort of a game of thousandths of an inch. You take what you can out of one place and take it out of another place, and hopefully in the end there's 60 thou to clear it. So I'll just start to dig into that again this winter, and we'll be getting back into that hopefully to see that on the track come spring. All right, thanks for watching.